Hello, this is Mr. Allison, and now we're doing IXL section P13, convert equations of conic sections from general to standard form. So basically we got to remember what the standard form of each of those conic sections is. So I'm just going to pop back here and just sort of look at this. Okay, so we have parabolas, which is y equals x squared or x equals y squared. We have circles, which is going to be x squared plus y squared equals some sort of a constant. And then we're going to have ellipses and hyperbolas, which we have been studying. And the only difference between those two is that plus or minus in between them. And of course the shape, but they both equal 1. So that's what we're going for. So now we'll go back here. And there we go. So that is some sort of equation. And the question is, what kind of equation is it? And we don't actually, and I don't know if we're going to have to answer some of the later ones if they're going to make us figure it out or not. But that's a hyperbola. So that is going to be something. So remember, if you want the easiest way, start by just writing the general form of the equation, right? X minus h squared over a for a hyperbola minus y minus k squared over b, that's a squared, and that's b squared equals 1, right? So now we got to change this into that form. So what are we going to do? Well, first we notice there doesn't really seem to be anything that would push into the formula where you'd end up with an h or a k, right? So let's start by moving that 36 over. All right, so we're going to go 4x squared minus y squared equals 36. And now we're going to divide. It's a hyperbola, we know, so we're going to have to get a 1 over here. So we're going to divide that by 36. And then we'll divide this by 36, and we'll divide this by 36. And we'll rewrite this, and 4 times 9 is 36. So this is going to be x squared over 9 minus y squared over 36 equals 1. And that's going to be the answer. So let's put it in. These just take a long time to type, don't they? X squared over, oops, not p, over 9. Yeah. All right, minus y squared over 36 equals 1. Don't forget the equals 1. It'll cost you. Okay. There's that. See if we want to. I just want to get a bunch of different ones. Okay, so there's another hyperbola, right? So the only thing you have to do, with this one is remember it has to be something minus something. So we got a positive y and a negative x. So this hyperbola is going to be y squared minus x squared equals 25. But we can't have. We got to have a 1 over there to do a hyperbola, right? So we're going to go divide by 25, we're going to go divide by 25, we're going to go divide by 25, and then we're going to get y squared over 25 minus x squared over 25 equals 1. And that is the way that one works out. Let's just type it in here, y squared over 25 minus, so this is going to be up and down one because it's got the y first instead of the x first, right? In case we had to graph that or whatever. X squared over 25 equals 1. And that is basically the same thing. They keep asking about hyperbolas. I don't know if they're going to get to anything else. We'll see. Jump a level, right? Okay, they're still asking about. I wonder if these are all going to be. The title is convert sections of convert equations of conic sections from general to standard, but they keep saying, but so far all I've gotten is hyperbolas. But that's okay. We can do hyperbolas, that's fine. So this we have, I'm just going to rewrite it because it helps me kind of get going on. 2x squared, I don't like to start with that color. Why? I don't know. 2x squared minus y squared plus 4y minus 66 equals 0. Okay, so we're going to have to complete the square on this y part, right? So let's do that. We're going to have to complete the square on this. So we're going to go, it's going to be 2x squared minus, and then we're going to do this completing the square thing, which is going to go like this, y squared plus 4y, and then we're going to go plus 4 over 2 squared, and that's that one. And then minus 4. I might be getting this one wrong. I'm not sure I'm dealing with the minus correctly. We'll find out, won't we? So that's going to be 2x squared minus, and this is going to be, what's that going to be? 4 over 2 is 2 times 2 is 4, so that's going to be y plus 2 squared. And then it's going to be 4 divided by 2 is 2, square root is 4, minus 4 minus 66 equals 0. So then we're going to have 2x squared minus y plus 2 squared, and then that's going to be negative 7 is going to be plus 70 over there. Boy, I don't like the way this is shaping up. I think I might have messed with that. I think I might have treated that minus incorrectly. But let's just do what we have to do here. 70, 70, 70. So now it's going to be x squared over 35 minus y plus 2 squared over 70 equals 1, right? Boy, I am in low confidence mode right now. Are you ready to see me get one wrong? I bet you are. I don't know what I meant by that. Here we go. I'm going to keep talking through this, and then we'll find out how badly I messed up here in one moment. Yep, see, I knew it. What did I do wrong? Yeah, I did the minus. Let's just go through that together. I knew I was not probably doing that correctly with that completing the square. And it was all in that minus, right? It was all in the minus. All in this area right here. This area right here, this thing right there. I treated that incorrectly. And I got all messed up. Because if I would have had the minus correct, that would have been 62 and everything would have been good. So let's just go through it together, shall we? Okay, we know about that. That's all the standards. Okay, so let's see here, right? What are they doing there? Okay. Right, okay, so we, let's just look at the actual one, because it was the way I did the minus, the way I treated the minus. So first, make sure all the terms are on the left-hand side. So we did that, and then hopefully going through this error will help you. this is the piece right there, right? That's the piece, that's the troubling piece. Okay, so the only term in x is 2x squared, so you don't have to worry about that. It's already done. Since the y coefficient is -1 and not 1, okay, so this is where I ended up with my problem. Factor the -1 out from the y terms before completing the square. And then when you regroup the terms, be sure to distribute the -1 appropriately. All right, so let's look at this. So this is where we were right here, right? And then oh yeah, see, that's definitely what I did right there. I should have that's whenever you have a coefficient and you're completing the square, you want to factor that coefficient out somehow, because you don't want to try to complete the square with the coefficient on the highest order term in the thing you're trying to do. So they put the whole thing in parentheses and then they factored out the -1. So then they ended up with that. Okay. Yeah. All right. I'm sure we'll hit another one. And hopefully walking through the explanation was helpful too. And if not, well, I hope you fast forwarded it. All right. So this one does not have, it's completing the square, obviously. Oh, a circle. Look at that. Nice. Do you remember the formula for a circle? X squared plus y squared equals a something, right? So this one is not difficult, right? X squared plus y squared equals r squared, as a matter of fact. But also equals a constant. So let's put that in there. And x squared plus y squared equals 9. Just so you can see that this is the same thing as an ellipse where the two foci have come together in one place, right? So let's just rewrite this in the form of a circular ellipse, just for your edification. So I'm going to divide that by 9 because I need that to be a 1. Then I divide that by 9 and that by 9, right? So now I can write this in the form of an ellipse, x squared over 9 plus y squared over 9 equals 1. And now it is an ellipse, but what's going on with this ellipse? The A and the B are equal, right? Which means the eccentricity is, it isn't eccentric at all. It's a circle. If A and B are, if both axes are the same, then it's a circle. So that's what we got, a circle. Let's erase my stuff. Write the equation in standard form of the hyperbola. So there, all we have to do, a hyperbola, this is an x minus y. What does that mean? It's going to mean this way. H and k are 0, right? So, there's nothing there. And all we got to do, we got to get a 1 right here, right? So how do we get a 1 there? We divide that by 49, which means we're going to divide that by 49. And that by 49. So we got x squared over 49 minus y squared over 49 equals 1. And that's all we have to do there. So x squared over 49 minus y. Now, why isn't that a circle? It's because there's a minus there, right? Y squared over 49 equals 1. Oh. Okay. We'll erase that. Oh boy, look at that. We have a double completing the square. Okay, so first of all, it's an ellipse, right? And if you remember the formula for an ellipse, it's x squared minus h over a squared plus y, oops, not that, jeez, y minus k squared over b squared equals 1, right? Okay, so I'm going to erase that because I need all the room I can get now. So now I'm going to put the x terms and the y terms next to each other to make completing the square easier. Plus 4x plus 5y squared minus 30y plus 39 equals 0. Okay, so for the first piece here, that one is pretty easy, right? Because there's no coefficient in front of the x. So that's just going to be x plus x squared plus 4x, and then plus 4 over plus, and that's going to be 4 half of this, half of that other coefficient squared, right? And then minus half of that coefficient squared, right? So that's just going to be x squared plus 4x plus 4 minus 4. So that all is the same. So that's going to be x squared plus 2 squared. And then we're going to have that minus 4. So there's that completing the square. Now we're going to have to do something here, aren't we? So what are we going to do? Well, first we're going to change pen color just so it's easier to follow. And then we're going to factor out a 5 and then complete the square inside, and then we'll put it back in. Or we'll leave it out or figure out what to do with that. Okay, so we're going to go plus, and it's going to be 5, and it's going to be y squared minus 6y. You see, that's the same, right? Plus 39. Now I'm going to have to go kind of slow. I didn't rehearse any of this. So I'm going to have to go a little slow here for a moment to make sure I do this all correctly. Okay, so that's the same. Now we're going to complete the square inside there, but then we're going to have to take that 5 back into account at the end. This could get a little hairy. So it's going to be 5, and then it's going to be y squared minus 6y. And then we're going to get a plus 9 and a minus 9. That plus 9 is the squaring thing, right? Because, excuse me, because it's 6 divided by 2 is negative 6 divided by 2 is negative 3, but negative 3 squared is 9. So that's what has to go there. Okay, so I haven't changed the value of anything still. I'm just rearranging. All right, so now this is going to be plus 5, and then this is going to be y minus 3 squared minus 9 plus 39 equals 0. Okay, so now what is the best thing to do here? I guess we got to plug that 5 back in for now, don't we? All right, so let's rewrite the whole line. Get back to our, so this is going to be, and I'm gonna move that. You don't know, I'm not going to move that yet. So I've got x squared plus 2 squared minus 4, that's just a constant, plus, and now I'm going to distribute that 5, and I'm going to go 5 y minus 3 squared minus 45. Did I do that right? Yes, I think I did. Plus 39 equals 0. All right, so now I got to do, I got to get the constants over on the other side, right? So we've got negative 4 and negative 45, which is going to be negative 49, and positive 39, which is going to give us a negative 10, which is going to become positive 10 on the other side, right? So let's just make sure I'm sure I did that correctly, but I'm going to go like this: 39 minus, 39 minus 4 minus 45 equals negative 10 on that side. So it's going to be positive 10 on this side. Okay. And now I've got, and we might just have enough space down here. So now I've got x plus 2 squared. We don't have to worry about this, or this, or this, because we just took care of those, right? And it's an ellipse, so that plus works fine. Plus 5 over y minus 3 squared equals 10. All right, so now what's the last thing we have to do? We have to get that to a 1. So we'll divide that by 10, and divide that by 10, and divide that by 10. And it looks like some of my writing didn't take for some reason. Is that right? Y minus, and that's a 3. Maybe I'm standing too close to the board or whatever. That should be a plus. Okay. Now let's rewrite that over here. X plus 2 squared over 10 plus, and then 5 over 10 is 1 over 2, so that's going to be y minus 3 squared over 2 equals 1. All right, so it's kind of ugly and messy, but I didn't do anything super complicated, right? It just got a little messy in the middle there. And now let's see if I actually managed to keep track of everything I need to keep track of and get it right. How much time I got? I got 2 more minutes, so that's what I got. So that's going to be x plus 2 squared over 10 plus y, and it's supposed to be minus 3, right? Minus 3 squared over 5 over 10 is 1 over 2. And that's going to equal 1. And I think that's going to be it. Let's just see, shall we? Boom. Hey, how about that? I got it right. And now I'm out of time. So I'll probably make a second one if anybody needs it. But that is, if you could do that one, you probably can do just about any of them. This one you see, if you put the y's and the x's on the same side, one of them's going to end up negative, right? It looks like you're going to end up with a, if it were me, I'd probably move the y squared and the 4y term over there. So I'd have a y squared term minus an x squared term, which gives us an up and down hyperbola. And anyway, there it is. Bye.